Hi, I'm Nguyen, Director of GNC and Performance at Relativity Space. And since you asked, what are the major challenges for the GNC team during ascent, staging, and reentry? I'm going to talk about the control aspect of this today. So the control algorithms utilize different actuators like motors or different valves in order to control the rocket to point in the direction that's determined by the guidance algorithms. When the engines are firing, we use something called thrust vector control or TVC control. And what this is we will rotate the engines about a gimbal point in order to use the thrust of the engine to create a torque about the rocket, and we can use this to actually turn it to steer it into the direction that we want it to go. The most challenging part of flight for TVC control is during ascent, during a phase that we call max Q or maximum dynamic pressure. So during ascent, Terran R is aerodynamically unstable, so what that means is the dynamic pressure actually makes the rocket want to flip around and point with the nose in the opposite direction of the flow. And so we actually rely on TVC control to stabilize the rocket and point it in the proper direction. It's kind of like taking an umbrella and holding at the handle and trying to push it into the wind. The wind naturally makes the umbrella want to flip around, but by kind of moving the handle around and controlling it, you can kind of find an equilibrium point to kind of hold the umbrella stable and pointing into the wind. And so on top of all of this, the control gets all the more difficult when you include higher fidelity effects like the rocket flexing around or the liquid propellant in the rocket sloshing, and these can be destabilizing effects for the rocket. So control engineer's job is to mitigate these things using different hardware and software.